to the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded and a copy of the slides and recording will be available for viewing later today. This can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Adrien.
Hello, good morning and good afternoon. My name is Adrien de Beaupre and I'm here to talk to you about NoSQL Injection. This is the part of a series of modern web application penetration testing techniques that I've been giving for the past several years. It's the third in the series, and it's a portion of a class that I am both the co-author and one of the instructors for with the SANS Institute. It is SEC 642. So 642 is the Advanced Web Application Penetration Testing, Ethical Hacking, and Exploitation Techniques class. Within it, one of the sections is NoSQL Injection. So this is a portion of that class presented to you. Now, if you have any questions, please do ask them. I'll get to the questions towards the end of the presentation, but please do feel free to ask them, and Sam will either read them out to me or I'll get to them at that time. So without further ado, let's step in. So what is a NoSQL database? Simply enough, it is not a relational database. A traditional relational database is made up of tables and fields. So for example, you might install MySQL or Microsoft SQL Server or Oracle or Postgres. Any one of those, they are all considered relational databases. This format goes back to the 1970s. And within each database, again, you have these tables and fields. Each field will have a name and a value. Now, more recently, within the past few years, there's a development called a NoSQL database. Now, NoSQL stands for not only or not SQL. And here's some very clear differences between a NoSQL database and a relational database that uses SQL, sometimes called SQL. So, very different. In NoSQL, there are very few standards between the different platforms, and there is no common query language. So full stop right there. SQL, or Structured Query Language, is a standardized language between all relational databases. So NoSQL databases don't have that. Also, commonly, relational databases often have a number of security features. In a survey across NoSQL databases, we found that the security features that we would normally expect to see inside databases are not necessarily there. For example, normally we would expect an authentication process to be there. In NoSQL databases, authentication is not necessarily enabled by default, and if it is available, it's not always supplied by the database itself. It may require additional software to provide authentication service for you. We're talking about between the application on the server and the back end. Does the application on the server require authentication to the back end? And the answer is, with NoSQL, not always. Another common feature we expect is that the access the application has to the database will have some form of access control. We found that across many NoSQL databases, that even if they require users to authenticate, there is no such thing as a role, meaning that all users have access to every part of the data. So here's two big differences right off the bat. That authentication is not always there, and if they require authentication, there may or may not be any form of access control or concept of authorization inside the database. That's a pretty clear difference right there. Next one, the third A, auditing. Not all NoSQL databases perform logging. Some others require some additional software to perform the logging for you. This is between, again, the application and the database, whether or not auditing and logging is performed of actions performed by the application. There may or may not be encryption between the application and the database. As well, there may not be encryption inside the database. Not all of them perform data encryption features inside the database. In traditional relation databases, this might be field level encryption. So there's some very, very strong differences between relational and NoSQL databases in the security features available. And this is the highlight slide that demonstrates in our survey some of those results. So another survey performed by a third party is, well, what are the databases out there? This is a survey of databases used on the internet. So one clear difference here might be databases used in, oh my goodness, I just realized I'm not advancing the slides. So I'm sure someone mentioned that in the questions. So there's my first slide. I'm sorry, it's 3 a.m. here in Canada. There's the second slide where I was talking about the security standards. And I'll leave this slide up so you can look at it. Again, going back to the definition of security standards, there's no common query language. Authentication is not always enabled. Access control may or not exist. Auditing may or not exist. TLS or transport layer encryption may or may not exist. Encryption at the file system may be enabled, but inside the database, field level encryption may or may not be enabled. I'll pop one step forward. This is the slide that I realized I'm not advancing the slides correctly. So among the databases available around the world on the internet, some of them are no surprise. Let's take a look at number 1, 2, 3. Oracle, MySQL, Microsoft SQL Server, and number 4, Postgres. These are all very traditional relational databases. We expect to see those in the top 10. 5, 6, 7, 8, 9, and 10 are all kind of surprises. Look at these. So MongoDB is a NoSQL database. I'd never heard of it before 5 years ago, and there it is in the top 5 of all databases used by applications on the internet. IBM DB2, if you've not heard of it before, is a very traditional relation database used on IBM mainframes since the 1970s. This product has been around that long. Now, the next two, Elasticsearch and Redis, are also NoSQL databases. These are not relational databases, so that's new. SQLite is kind of a relational database, but it's kind of like Microsoft Access. It's really just a file. But the last one, Cassandra. So if you look at the top 10 databases used on the internet in common web applications, we have Mongo, Elasticsearch, Redis, and Cassandra. 1, 2, 3, 4. So 4 of the top 10 databases are non-relational. This is fantastic. This is incredible. This should cause us to question, so what's going on here? Something has changed. And the clear difference is, let's be honest, relational databases are slower. To achieve web scale performance, you require a NoSQL database. However, you trade performance for other things. You get higher performance, but you lose things. Now, MongoDB appears to be one of the most popular. I've some experience in Mongo. I've spent some time researching this since I wrote these slides almost 4 years ago. So MongoDB is a document-oriented database, meaning it does not have fields or tables. It has documents. It does not use SQL or structured query language. The queries are in JSON. So JSON is JavaScript object notation. If you're familiar with Python, it's very much like a dictionary. So everything is in name and value pairs. Actually, they're actually stored in a format called BSON, Bison, or binary JSON. So here's a very, very clear difference. In a relational database, the schema, meaning the design of the database, the fields and the tables and their primary keys, that's the schema. In a schema of MongoDB, it is dynamic, and if you insert new name value pairs, you just change the schema. It changes on demand. The next one is a game changer. This is one of the biggest differences between a relational database and a Mongo instance is that Mongo queries can and choose include JavaScript. Let's stop there for a moment. Okay, so JavaScript runs in our browsers. Interesting. JavaScript can run on the server with Node and Express. And in fact, Node and Express running on the server are often paired with another JavaScript framework called Angular running in our browser. So we have JavaScript and we have JavaScript frameworks running in our browsers. We have JavaScript frameworks and servers, Node and Express running on the server. The missing feature here is the back end, which is Mongo is the database. Mongo can also run JavaScript. So we have JavaScript now ubiquitous across all layers of our traditional application stack. Now here's kind of a joke, and I apologize if you've not seen the movie. Mongo, only pawn in Game of Life, which is a reference to a really horrible movie from the 1970s called Blazing Saddles. But in any case, Mongo is a character in that movie, and he says that line, that Mongo only pawn in Game of Life. Later on, Mongo blows up. In any case, so JavaScript, really interesting. So both SQL, meaning relational databases, and NoSQL have some very interesting and very important differences in their approaches to data. So SQL again, going back many decades, is ACID compliant, meaning that they all try to adhere to these principles: atomicity, consistency, isolation, durability. So maintain consistency even if it slows us down, even if it limits scalability, which means, for example, relational databases often do something called journaling. Journaling meaning they save a copy of all the transactions that they've written to the database. So if you suddenly cut power to the database, you should be able to recover the database and replay the journal to see what has happened since your last snapshot. So you get that consistency, that ability to recover, but it slows you down. On the other hand, NoSQL is these key or name value pairs. And different NoSQL databases call them different things. Mongo calls them documents. React calls them buckets. But the clear difference here is the principles that guide them. The principles here are basically available, soft state, eventually consistent. Kind of, maybe. In fact, the most NoSQL databases attempt to keep all data in memory all the time, which means never ever write to disk. Now, if you think about that, if you never write to disk and you don't keep journals, what happens if the power is cut? And the answer is the data goes away. It goes bye-bye. It's gone because you did not write it to disk. There's a very clear trade-off between consistency to attain scalability, where honestly, the left-hand side SQL is slower. The right-hand side NoSQL is much, much, much faster. But an example here is, if you query a NoSQL database 100,000 times, you might get different answers. Think about that. So another clear difference is the language. So on the left-hand side, we have SQL, structured query language, using MySQL. An example would be select, which is a very common method of accessing data. Select star, meaning all of the fields from users where ID equals 1. This is an example where we're selecting something from a table where we're specifying that the field ID equals a value of 1. And that will give us a response. We can update. So the update query is update users, setting password equals an input possibly from a user where ID equals input from a user. We can also create a table, users, where the ID and the user ID have certain values. On the right-hand side, we have the NoSQL equivalent with MongoDB, where they use db dot. Now, traditionally, meaning some time ago, the db dot commands were accessible through many of the frameworks that had access to Mongo. Most modern frameworks do not allow you to access the db dot commands inside Mongo anymore, which is a good thing. This means that the frameworks are getting better at security. So, but the framework itself might run the db dot command. So db dot users, where users is the collection or document or database, dot find is the function, and then user. Then we might have an update. Now, but I might point out, notice the format of the find. So db.users.find, left bracket, curly brace, user ID :1, right curly brace, right bracket. The format there is the JSON, user : value, the name value pair. So an example update is db.users.update of that JSON again, or the dictionary, user ID : where you have a value inputted, set password to an input. And to create a table, it's db.creation collection users. So the point of the slide is the syntax is very different. Also meaning that the methods that applications use to access data on both sides between SQL and NoSQL are very different. Now, here's a conversation, a replay of some years ago, although not that many years ago, between a security team and a development team. And we're talking about SQL injection, and the development team says, oh, we are not vulnerable to SQL injection. And the answer was, you are correct. You are not vulnerable to SQL injection. However, you are vulnerable to no SQL injection because you use MongoDB. And there was silence across the room. Then someone at the back of the room says, well, that's not a thing. I think you made that up. The answer is, we did not make it up. This is actually a thing, that there is a vulnerability called no SQL injection, and it exists in applications that use MongoDB. So traditional SQL injection using SQL map, does not work here. But consider the application may have variables that are transported or passed between the application and the backend database via, for example, a REST API endpoint that contains JSON, and the JSON becomes the query into the database. So imagine now the attacker understands this and can control portions of the parameters inside the JSON that are passed to Mongo, the backend database, running, you guessed it, JSON queries. This is where we have injection. Now, most often, the input from a user becomes part of a where clause or $where operator, very similar to an SQL where clause. Now, going back, in some older versions, you could introduce the db. Commands. For example, db eval, mapreduce, and other group operators. For the most part, injection directly into db. Commands is not necessarily allowed, but most often we are allowed to inject inside of queries, like the where operator. So look at the bottom of the slide, where we have parameter injection like so. victim./login question. So up to that point, it's basically the resource URL. Then we have user square bracket $NE square bracket =1. This is a feature of HTTP, whereby the square brackets on the left of the equal sign indicate that this is in fact an array. So traditionally, you would not have the square brackets there. You'd have login question user equals 1. Perhaps and password equals password, because of course the password is always password. That's a joke. So user not equal 1 in this case would become the array of all users not 1. And that's a real interesting thing. So it's a feature of HTTP. Now this does depend upon the language running at the back end. If, for example, the back end is running PHP as its framework, PHP is loosely typed and will allow you to specify that, oh, by the way, this thing that I thought used to be a string is now an array because square brackets in the HTTP GET request or in the POST contents. So this might return all users not equal to 1. Depending upon what that query does, if it's a login feature, it might log us into someone else. If it's a different feature, it might give us all of the users. So things to try if you're fuzzing or attempting to attack MongoDB. Well, try inserting JavaScript because Mongo runs JavaScript. But you have to imagine, right, that what type of attack we're talking here? You said, Adrien, this is injection. Yes, so we're injecting into something running on the database through the application, which means, of course, the application itself and the framework it's written in, whichever it be, could do validation on inputs. So this is a lack of validation. But if they do not strip out JavaScript, in fact, the JavaScript may run in the context of the Mongo instance. You can also insert JSON and see what happens there. You can try and insert things that would trigger database errors on purpose. In traditional SQL injection from, goodness, that would be almost 10 years ago, you could inject errors into the database and see them come back into your browser. Now, with SQL injection, meaning relational databases, those errors are mostly hidden from us, so we don't see them anymore, and we have blind SQL injection. In more modern NoSQL injection, we often, believe it or not, still see the errors. So we have JavaScript, we have JSON, we have attempts to introduce syntax errors where we might see the error response. We can try and insert logic. Look at the logic there, quote, pipe, pipe. Well, pipe, pipe in this case means or. So quote, or 1 equals 1, semicolon, slash, slash, which in this case, semicolon, slash, slash says that's the end of the line. Ignore the rest being a comment. So commenting out things is slash, slash, but most importantly on this entire slide are the operators. These are things that Mongo understands. Where, greater than, less than, not equal, and regex, or regular expressions. The last comment on this slide is Mongo commands, you can try and do them directly. In most cases, Mongo versions that are more recent will not allow you to do direct Mongo commands from web applications. In some older implementations, these might still work. So we have things to fuzz. We also have a methodology. The methodology is here very similar to SQL or SQL injection. First, start with a query that answers yes, meaning I am true. So this is called a baseline. When you use a tool like Burp Suite. Burp Suite Intruder, one of the tools inside Burp, has a method of doing fuzzing. It is the fuzzing tool inside Burp. And when you run Burp Suite, it always is a baseline or the original request. We traditionally want the original request to return true. The next step is look for errors. Introduce fuzzing strings, things that will cause errors, and see if we see the response from the database indicating syntax errors. Then try to inject operators that modify the query. In this case, you may actually modify the logic of the query. Remember, my friend, not equal. Try other logic to return multiple records. Try perhaps, now this one's dangerous, so be very careful, inject new records to modify the schema. Or even more dangerous, delete or modify records. You may have seen little Bobby drop tables. This is a XKCD instance that told you that if you can change an introduction, if you can introduce a change into a parameter that becomes part of a database query and insert, drop table, that might be a problem. You can also, in this case, inject JavaScript, inject JSON or BSON directly, or the last case is interesting. In some cases, you install Mongo or some of the other databases, and they implement a REST API or some other management interface that perhaps may allow you to access the database directly. Some time back, Mongo used to bind to every IP address with no authentication required. Now, traditionally, you would probably rather your database bind to localhost only, meaning only be accessible local to the application and not on your public IP address. But Mongo would bind to your public IP address also, which meant that, well, since there was no authentication, anyone could access your database. So that'd be probably a bit of a drag. For tools, there are surprisingly not that many tools out there. I've run across a few. There's NoSQL Map, which is an attempt, of course, to be similar to SQL Map or SQL Map. There's the NoSQL Exploitation Framework. There's inside of FuzzDB. FuzzDB is a collection of strings for performing web application attacks. There's also Burp Suite Pro and OWASP Zap. So we have a bunch of tools. Now you might also wonder, well, what about the commercial application scanners? So my experience there is with AppScan, now Fortify, WebInspect, now Fortify, and some others like Acunetics and NetSparker. Most of them have some coverage of NoSQL databases, but I'll tell you, almost all of them only cover MongoDB, which means there's probably some other databases. Let's, for example, call out Redis, Cassandra, Memcache, and some others that there is very limited coverage by any of the tools to determine if you are vulnerable to NoSQL injection into those databases. Now, when I wrote these slides, I was also searching for applications that are vulnerable because I wanted to have an example. One of which is written for this course by my friend DigiNinja, also known as Robin Wood. Robin lives in England, I believe Northern England, and I had barely met him online when he agreed to write this application for this course. You'll see it very shortly. So DigiNinja wrote one. There are additional testing pages written inside the tool NoSQL map. The Web Securify blog on NoSQL injection has an example, and there are probably some others. Now, I'm going to argue, and you can argue back with me, that most applications that have vulnerabilities, the majority of them are not written on purpose, meaning that the developers, we assume, do not put the vulnerability inside the application intentionally. Although you wonder sometimes. We'll talk at the end of the talk about there's actually some other actually, no, it's this slide. So you might wonder, like, so is MongoDB NoSQL injection a very hypothetical attack? Well, no. CVE 2017-1000493 had a CVSS version 3 base score of 9.8, which is pretty darn close to a perfect 10. It's an application called RocketChat Server that is vulnerable to NoSQL injection, that if you added your own account, which is allowed in this application, you could add your own account, register yourself, then you could query the administrator account information, then you could send a reset of the password of the main account, and then through NoSQL injection, you could actually recover the token sent to the administrator and actually take over the administrator account. And the reference at the bottom there is of the write-up of this attack. That's actually not the one we're going to demo. All right, so I tell this joke a lot. So when you do a live demo, you should, of course, sacrifice something to the demo gods. Normally, you know, I would joke and say I'd ask for a virgin goat, but of course, no one in their right mind would sacrifice an actual goat. Goats are very nice animals. So no live animals are harmed in any making of any demos. Alrighty, so we're going to switch over to live demo mode. I'm going to pop up the VM and pause for a moment. And at this time, you should see my virtual machine and see a Linux VM with a NoSQL attack lab. This is the attack lab, again, written by my friend Robin Wood, DigiNinja. Just going to increase the view a little bit. So there are three different ways to play. We're going to first click on the first one, guess the key. Guess the key. My guess, oh, I don't know, 42. Click on guess, and it says no match. Oh. I'm going to guess quote. And look what happens. It says, oh, I'm going to give you a stack trace, which is super cool because now I get to see some of the code that runs on the back end. And it says right here, var guess equals quote, quote, quote. That's exactly what it didn't like. That's the quote I inserted. And that's the code around the quotes. And it says if key equals guess, return match. Else, return no match. Well, I saw no match because I put in something else. I put in 42. Now, 42 is, again, a bit of a joke. It's the answer in a book series called The Hitchhiker's Guide to the Galaxy by Douglas Adams. But if you think about this, okay, so key is something interesting. I don't know what key is. I know what guess is because I put in guess if key equals guess. So what I really want is key. So looking at what's in there, if I put in quote, that will terminate part of the query, semicolon, return key. Now notice where I get the idea to return. Right there it says return. So return is what comes back to me, because I know no match came back to me because there's a return no match. So return the key. The key is what I want to see. So quote, semicolon, return key, but now I want to finish off what's going to happen after me, semicolon, slash, slash. I'm putting in code to basically tell the application, psst, give me the key. Usually I put a space right there. I don't think it's required, but anyway. And it says, hey, the key is Magrathea. So based on putting in a quote that gave me an error, where the error contained a stack trace, I can construct code that tells the server to give me the answer. Excellent. Here we have NoSQL injection. I'm going to click on Home and try User Lookup. User Lookup, it says, challenge, guess the details of an administrator. So I want to be admin. It says Sid is a user. So let's try something invalid first. Adrien, guess. It says username invalid. Cool. Then I try Sid and said, ooh, something different. Now here, let's take a look at what went past us. And we're going to do applications, oops, text, Control V. I want to see a little bit. So here, that's the resource question. So everything after the question is what we're interested in. Type equals user and username equals Sid. Well, I don't want to be a user and I don't want to be Sid. So what if I put in here $not equal? I don't want to be a user, and I put in here username $not equal. I don't want to be Sid. I want to be not a user and not Sid, and I want to try that in the application, that portion, and see what happens. And it says, oh, you're admin. In fact, your name is Penny. Penny Dog. Now, this application is available. You can download it from Robinhood Digi Ninja. But here, he actually gives the example. If you click on Show, it shows the example. So one is not equal. So when I showed you, there's actually a second one using regular expressions. So if you look at the regular expression, I'll copy that and put it in the text editor. It actually uses $regex equals .star, meaning any, $regex equals .star, meaning any. So any says dump all of the users, including admin Penny. So there's more than one answer to some of these questions. Going back to home, and login. So we want to do an authentication bypass. All right, so I'm going to try things that will not work. I'm going to try foo and bar. Login. Let's take a look at what we have here for parameters. Type equals user. Username is foo. Password is bar. All right, so I can work with this. I want to bypass the first part, but let's try one more test. It said user not found when I typed in foo and bar. Let's try sid and a password of password. And notice it says something different. Sorry, you entered the wrong password. So a logically invalid username of foo said wrong username. A logically correct username, meaning sid, told us wrong password. So this allows me to assume things about the application, that the error messages are different if you have a valid password, or sorry, valid username versus valid password. So what if I change type $not equal user and username $not equal foo? But the password, I don't know the password yet. But I'm going to try that to insert into the application. And it says wrong password. But if you look at what I inserted, I'm not a user and I'm not foo, which should to the applications mean that, well, if you're not a user and you're not foo, you're probably administrator. But I don't know the password. So here's the interesting thing. And I showed you the answer. The answer to the password is bar, put in a quote, or quote one quote equals quote one. This is effectively 1 equals 1. So let's talk about that for a sec. 1 equals 1 is a tautology. A tautology is something that is always true. 1 equals 1 is true. 1 not equal 0 is true. So or 1 equals 1 means return true. I'm putting bar quote or 1 equals 1 into the password field, which unfortunately, in this case, should give me a bypass of the third check. The first check is my username. The second check is my user type. The third check is my password. Whoops. And type equals any, username equals any. Foo and password bar quote or 1 equals 1. Oh, huh. I just made a mistake right there. You all saw me do it. I typed in 1 equal sign. My goodness. If I want a comparison, it must be 2 equal signs, not 1. 1 is an assignment. Wow. All right, you just saw a live demo fail, but I did get it right. So that was a pretty quick recover, right? Where I noticed that I put in only one equal sign into my query. So equal is a check, and it says, hey, you're correct, you're admin, and here's a super secret key. Wow. And here again, the application shows us the solution, which is the same from Robin. Alrighty, so it is now almost 4 a.m. in Canada, where I live, and where you are, it's probably 4 in the afternoon. So at this time, I'm totally open for questions. If you are curious, this is a portion of the course, SANS Security 642, Advanced Web Application Penetration Testing, Ethical Hacking, and Exploitation Techniques. I have taught it in Singapore, Australia, and Japan. And I'm willing to come back when, of course, the pandemic is over. We are doing a massive rewrite of the course now. We'll be featuring portions of the new content in the now timeframe in July of this year. And then in September, October, November, December, later this year, we will have the new version available. So if you want to see a preview, sign up for the July version, which is sooner. The release of the official new version will be probably September, possibly October, November, December. So we're open for questions. Pass them to Sam.
Thank you. Really appreciate your time today. Thank you, Adrien. A couple of questions that have been asked and quick answers for you. A copy of the slides and recording of this webcast will be available for viewing later today, and it can be found on the SANS registration page. Second question was in regards to whether or not this presentation was part of the official SANS 642 class, which you've answered just previously, Adrien. So yes, it certainly is part of the SANS 642 class. So if you liked it, look at getting in there and registering for the full course. I'll give people another sort of 30 seconds to a minute if there's any other questions that you'd like to propose for Adrien.
Yeah, I'd like to add that the NoSQL injection part of the course is much more extensive. This is just part of it. And we have many new topics. We have JWT, we have attacks against SAML, we have attacks against XXE, we have all kinds of brand new content coming towards you. So please do consider signing up for the class.
Perfect, wonderful. Well, if there's no other questions, just like to thank you again, Adrien, for your great presentation, which has helped to bring that content to the SANS community. To our audience.
No, thank you, everyone. Also, let me throw up the last slide, which is contact info. Please feel free to contact me at my email address or my Twitter at AdrienDB. I'm fully available to questions, email or Twitter. I don't give you my cell phone because I don't want you to call me at strange hours in the morning. But please do feel free to reach out at any time about any questions about application testing or the course.
Perfect.
So any last questions?
Yeah. Is SEC 542 the perfect roadmap into SEC 642?
Yes. If you've taken 542 or something similar or have equivalent experience, please do consider 642. Yes.
Great, but it's not a prerequisite.
It's not. If you have equivalent experience or some other course, try it.
Perfect. Well, thank you again, and thank you to our audience. We certainly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. You can find your CPEs for all completed webcasts by logging into your SANS portal account, navigate to your account dashboard, then click My Webcasts. You can then download your CPEs on the right-hand side of the web page. Until next time, take care, and we hope to have you back again for our next SANS webcast.
G'day, mate. Zai Jian.
Thanks, Adrian.
Ciao.